Hello, and welcome to RightScale, the leader in cloud computing management. Today we're going to talk about RightGrid, which is our scalable batch processing framework for handling grid applications in the cloud. What are the real benefits of RightGrid? The most obvious benefit is that in the cloud, you can now launch as many servers as you need to dramatically reduce your batch processing time. Remember, you are no longer limited by a fixed number of server resources. Next, there's automation. Manage and automate the entire process. Your server array of worker instances can automatically scale up and scale down based on scaling parameters that you define. You can also have an automatic schedule for handling all types of load management. One of the best parts about RightGrid is that it's quick and easy to set up and customize. Use our one-click RightGrid application to quickly set up a fully functioning RightGrid application. Then you can easily customize it by modifying just a few configuration files and scripts. RightGrid is also a cost-effective solution for batch processing because ultimately you control how many servers you use and for how long. Now you can really enjoy the advantages of cloud computing's on-demand, pay-as-you-go pricing model. To really appreciate RightGrid, we must first remember how grid computing and batch processing was done before the cloud. In the old way, you were always limited by the number of available server resources. And regardless of how many servers you had in your grid, hardware was always a major limiting factor. But in the cloud, you can now use cloud computing infrastructures like Amazon EC2 to scale up the number of worker instances to dramatically reduce your total processing time. Imagine launching 1,000 servers to process all of your jobs in less than an hour. And exactly how much would it cost to launch 1,000 servers on EC2 for 1 hour? Only $100. Certainly that's a rather extreme example, but the point is that you now have a viable alternative for batch processing that's both efficient and cost-effective. But this is why cloud computing is so amazing and why it's such a perfect tool for grid processing today. You no longer have to worry about investing in advance for speculated peak demand scenarios or try and maximize your utilization rates for existing hardware. For instance, you may have a co-location center with, say, 100 servers because you need to be ready for those 1 or 2 big jobs during the year. But most of the time, you might only use about 10% during a typical month. In the dedicated hosting model, you're always paying for the maximum number of servers. But in the cloud, you have a completely scalable architecture. Simply launch what you need and pay for what you use. The days of wasting money and energy on idle servers are over. And you'll never have to worry about not having enough servers for those big jobs, because in a way, you'll have access to the world's largest data center at the click of a mouse. Cloud computing also introduces a neutral cost equation, where it can now cost the same amount to process a job depending on how many servers you use and for how long. For example, it costs the same amount to launch 1,000 servers for 1 hour or 10 servers for 100 hours. All you have to decide is what's the right combination for you. How would you like to spend $100? And with RightScale's monitoring features, metrics, and scaling parameters, you can further optimize your RightGrid application to be even more efficient and automated. What is RightGrid? RightGrid is a back-end batch processing framework that provides a more efficient solution for processing a group of jobs or work units by taking advantage of the scalable compute capacity of cloud computing infrastructures such as Amazon EC2. Create an automated and scalable solution for any type of back-end batch processing task that will dramatically reduce the time required to process your data while also providing many cost-saving benefits. For example, you could use RightGrid for media transcoding, file conversion, or even different types of data analysis. So now that we've just seen how cloud computing can completely revolutionize how we do batch processing today, let's take a closer look at RightGrid to see how you can use it to control and manage all of your batch processing tasks. This diagram shows the core components of a RightGrid application. First, there is the job producer, which generates the work units that need to be processed. Now, the job producer can be anywhere. It doesn't have to be on EC2. A work unit consists of an input message that will be sent to the SQS input queue and the associated raw data files, which will be temporarily stored in your S3 bucket. Next, the RightGrid daemon on a worker instance will pull an input message from the SQS input queue and then download the associated data files from S3. Once a work unit has been processed, the resultant data files are sent back to S3 while an audit and output message are sent to their respective queues. Finally, there's a job consumer that determines what to do with the processed data. It's totally optional to have a job consumer, but you may want to have one, for instance, if you want to store the processed data files in your database so that they can then be served by your front-end web servers. You can even follow up with an email notification when processing is complete. So what happens inside one of these RightGrid worker instances? Each server will have your user application, which will process the raw data files, as well as the RightGrid daemon, which will coordinate the whole process. The RightGrid daemon constantly polls the input queue for new work units that need to be processed. If a work unit is present, it will grab the first input message that's available. Next, it will retrieve the associated data files from your S3 bucket and copy the files locally to the server. Once the data has been processed, the RightGrid daemon will send the result data files back to your S3 bucket and a message to the output queue. Now let's take a look at the configuration of our scalable server array. Each server array can be configured so that it scales appropriately for your own application. Here are some of the basic scaling parameters that you'll need to define for your array. Each server will be launched with the same server template. Here we're using a version of the RightGrid app worker. By using the same server template to launch and configure each worker instance, we can guarantee server consistency and replication every time. Our elasticity function is set to scale based on the number of jobs in the queue. Similarly, you can also scale based on time, or how long jobs have been sitting in the queue. You can also define the ratio of work units versus the number of servers. We've configured this server array so that it automatically launches a new server for every 10 jobs that are in the queue. For example, if at any time there are 70 jobs in the input queue, the server array will scale up to 7 servers. You can also define the minimum and maximum number of servers in order to control and limit the size of your array. Let's watch our server array scale up as the number of jobs in the queue increases. The server array will remain at 4 servers until it exceeds 40 jobs. The moment that there are more than 40 jobs in the queue, an additional server will be launched and added to the array. The array will continue to grow and scale up accordingly as the number of work units increases. Eventually, the number of work units in the input queue will go back down, but server arrays do not scale down in the same way that they scale up. Since you pay for server time on Amazon EC2 by the hour, it's in your best interest if a server stays operational for the majority of an hour, just in case there is another sudden increase in jobs. Otherwise, you could be launching and shutting down servers during the same hour when it's really not necessary. But by default, any unneeded server will automatically be terminated if it is not processing any work units at the 55th minute of a server hour. You also have the ability to create more complex architectures where you may have a chain of multiple RightGrid applications. For instance, the output queue for RightGrid application A could also be the input queue for RightGrid application B. In the same way, you could extend this chain even further to, say, application C or D. It's really up to you. Finally, we'd like to share with you a RightGrid success story. On April 14, 2008, Animoto launched a Facebook plugin for their web application that lets users create music videos with photos and music of their choice. Animoto set up a RightGrid application with a scalable server array of worker instances on Amazon EC2 to process all of their music videos. Their viral marketing strategy paid off, and Animoto's Facebook application quickly became an overnight success. And in just a few days, Animoto scaled from 40 to 4,000 servers. This type of growth and scalability would have been completely impossible just a couple of years ago. And after their initial spike was over, Animoto was also able to scale back down. RightGrid provided a graceful solution for scaling up their application servers in order to meet their batch processing requirements. Instead of purchasing 4,000 servers, they only had to pay for the EC2 server hours that they used. Now that's cloud computing delivered. And Stevie and the rest of the Animoto team couldn't have been happier with the results. Thanks for watching. To learn more about RightScale and sign up for a free trial, please visit us at www.rightscale.com.